So as we were saying in 1-1 part 1, we were about here with this line, finding the slope, etc. Um, I just want to show you, it doesn't matter what points you use. Here I'm going to use the point 4, 1 and 0, -7, those 2 points. Okay, and I'm going to take the y coordinates and subtract them. 1 minus -7. The x coordinates 4 minus 0. I get 2 for the slope. Okay. The x-intercept and the y-intercept are 2 points of where I cross the x-axis, that's the x-intercept. Where I cross the y-axis is called the y-intercept. And to get them, you simply put 0 in for the appropriate coordinate. To find the x-intercept, I would want to put 0 in for y. So where does 0 equal 2x minus 7? I would add 7 to both sides and divide by 2. It looks like that happens at about 3.5. X equals 3.5. So that means the point 3.5, 0 is my x-intercept. And I can verify that by looking at the line. To find the y-intercept, I would put 0 in for x. Y equals 2 times 0 minus 7. That means y equals 0 minus 7 or -7. But again, the y-intercept is easy to see when you're in slope-intercept form, which we're going to get to here. It's right there, -7. Okay, and I can again see that on my graph that my x-intercept is 3.5, 0, and my y-intercept is 0, -7. Those are important points on a graph. So this is our form, slope-intercept form. Y equals mx plus b. M is the slope. B is the y-intercept. If b happens to be 0, guys, then we have a proportion. Every once in a while, we'll talk about something being in proportion. That means that it's going through, the line is going through 0, 0, because the y-intercept is 0, and the y and x are proportional. So if I was asked to find the equation of the line with x-intercept of -4 and y-intercept of 6, and I was asked to graph that line, I have a couple of things I could do. The 2 things I need, remember, for the equation of a line is the slope and the y-intercept. Well, I know the y-intercept is 6, so I already know this equation is going to be y equals something x plus 6, okay? Because I know the y-intercept is 6. So 1, 2, 3, 4, 5, 6. I go through my y-axis at 6. I also know I go through my x-axis at -4. So 1, 2, 3. Right here, I can I can see this line. I can graph this line. Okay, that's not a problem. I'm not sure the equation because I don't know the slope of this line. So think about how I might find the slope of this line. I know it has an x-intercept of -4 and a y-intercept of 6. Can you think about how you would find the slope then? Okay, some of you might say, hey, why don't you count rise over run? I go up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4. Looks like my slope is 6 over 4, which I would reduce to 3/2. So now I can say, oh, I wrote the equation, y equals 3/2 x plus 6. Okay, if you didn't think about going up and over, if you know the x-intercept and you know the y-intercept, then you know 2 points on the line, right? If they told me that the x-intercept is -4, then I know I have a point -4, 0. If they tell me the y-intercept is 6, then I know I have a point 0.06. So I could find the slope by subtracting the y's, 0 minus 6, over subtracting the x's, -4 minus 0. So I get -6 over -4. A negative over a negative is positive. So I would have gotten the 3/2 either way. The equation is y equals 3/2 x plus 6. That will give me any point on this line. Okay, if you take any x coordinate and multiply it by 3/2 and add 6, you'll get the y coordinate. Okay, here they're asking me to find the slope and the y-intercept. No, they're asking me to find the slope and to graph this line, but it's not in my nice form. It's not in slope-intercept form. I don't know the slope of this. I don't know the y-intercept. Okay, so I have a couple choices. One choice is to rewrite this into slope-intercept form. I could subtract 8x from both sides, okay? Subtract 8x from both sides, and then divide by 3. That's one thing I could do. Sorry. So if I subtract 8x from both sides, I know I could write 5 minus 8x. I choose to write negative 8x plus 5, just because then I have it in slope-intercept form. Divide everything by 3. Y equals negative 8/3 x plus 5/3. It's a little awkward to graph that way. Remember, 5/3 is 1 2/3. So I know that my y-intercept is 1 2/3, almost 2. Okay, and then I'm going to go either down 8 and to the right 3, but that presents a problem for me here. So I can either go down 8 and to the right 3, or I can go up 8 and to the left 3. Either way, I get a negative slope, as long as one of them is negative. So I'm going to go up 8, 1, 2, 3, 4, 5, 6, 7, 8, and to the left 3. Okay, and that gives me, did I do that? 1, 2, 3, 4, 5, 6, 7, yeah, 8, and to the left 3. So now I can graph that. Okay, I use my rise over run. Another thing I could have done, again, is, if I didn't want to quite do that, I could have tried just to use some points in here. Okay, maybe stick 2 in for x and do the math to see what y is, etc. Okay, I notice here, oh, this looks like a nice point. It looks like I have negative 2, 1, 2, 3, 4, 5, negative 2, 7. Looks like it's a point on the line. Well, if I put negative 2 in for x, 8 times negative 2, that gives me negative 16, plus 7 in for y, that gives me 21. Yeah, negative 16 plus 21, that's 5. Okay, every point, every x, y on this line is works in this equation. We have the equation, we have the graph. Okay, notice what happens if I rewrite this without a denominator. I would multiply the denominator by the slope. And what this does is give us something new. It's called a point slope form. We don't use it a lot in algebra. It is used a lot in calculus. So I do want you to memorize this, okay? You take y minus the y coordinate. That's the same as the slope times x minus the x coordinate. We use that a lot when we have something like this, where it says find the equation of the line through these 2 points. Okay, 2, 9 is right here. 5, 3 is right here. Okay, so here's the line. I don't have the slope or the y-intercept. Okay, I would like to know the slope, and I would like to know the y-intercept. Well, I can find the slope by subtracting the y's and subtracting the x's. So that gives me 6 over negative 3. I get a negative 2 slope, but I don't know the y-intercept, and I can't guess what it is either. It's up there high, something bigger than 10. So I'm going to use the point slope form, and I'm going to choose this point. It doesn't matter which one, but I'm just choosing that. I'm going to take y and subtract the y coordinate. That's going to be the same as the slope, which I just found was negative 2, times x minus the x coordinate. So that's y minus 3 equals negative 2x plus 10. If I distribute the negative 2, add 3 to both sides, we get y equals negative 2x plus 13. And 13 makes sense to me that I might be going through the y-axis up there at 13. Okay, so I wrote the equation of the line using point slope form to help me get to the slope intercept form. Here I have 2 points, negative 4, 5, and 6, 5. If I would draw that line, it's this horizontal line where the y coordinate is always 5. X could be anything, but the y coordinate is always 5. Guys, that's a special, we don't really have, the slope there is 0. Okay, that's a 0 slope. It's not steep at all. It's a 0 slope. Here we have the opposite thing. We have -7, 6, and -7, -8. And then I get where the x-coordinate is always -7. The y-coordinate is whatever, okay? This equation of this line is x equals -7, and the slope is undefined. It's not 0, it's undefined, okay? If I would use the slope formula, -8 minus 6 over -7 minus -7, I get -14 over 0. And if you remember, you can't divide by 0, okay? That's an undefined number, so therefore the slope of a vertical line is undefined. Its equation is x equals whatever the x-coordinate happens to be, which in this case was -7. Here are all the equations of lines for you. Y equals mx plus b is the most famous. Slope of m, y-intercept b. Here's my point slope form, which we just learned. If it's a vertical line, it's x equals some number. Horizontal line is y equals some number. Notice with the vertical line, it's an undefined slope. Horizontal line, slope of 0. If I graph these 3 lines, let's see what happens. Take a minute and graph those 3 lines. Okay, hopefully you graphed those, paused it and graphed these. But -2/3 x plus 7, I went to 7 on the y-intercept. I went down 2 and to the right 3. I also went up 2 and to the left 3 and got this nice red line. I went to this one next because it's slope-intercept form. I went up to +1, which is the y-intercept. I went up 3 and over 2 a few times. Okay, and I got those 2. Now this one is in, not any of my forms. So what I do then sometimes is use something called the intercept method. I put 0 in for x, okay? If I put 0 in for x, it's like this term just goes away. So I have -2y equals 4. If I divide both sides by -2, 4 divided by -2 is -2. So 0, -2 is a point on this line. And then I'm going to do the same thing. I'm going to put 0 in for y this time. Okay? If I put 0 in for y, it looks like I have 4 divided by 3 as the x, which is 1 1/3. So it looks like my y-intercept is -2, and my x-intercept is 1 1/3. Okay, so we'll graph that. See if I can grab that a little better. What I wanted you to notice is we have some parallel and perpendicular lines here. Okay, if I would try to figure out the slope of this line, okay, I know the slope of this line is -2/3. Okay, this red one, I know this slope is 3/2. This slope, I'm not sure. I would have to subtract the y's and x's. So I'm going to take -2 minus 0 and 0 minus 4/3. That gives me -2 over -4/3. When I divide by a fraction, I multiply by the reciprocal, and that gives me +3/2. So both these lines, these black lines, both have a slope of 3/2. When the slopes are the same, the lines are parallel. The red line and the black lines are perpendicular. They intersect at right angles. Notice their slopes are opposite reciprocals. -2/3, +3/2. Okay, if your slopes are opposite, in other words, one's negative and one's positive, and they're reciprocals, meaning the numerator and denominators are switched, then you have perpendicular lines. So these are the definitions then. Parallel lines, perpendicular lines, same slope, they're parallel. If their products is -1, perpendicular.